Hi friends, welcome back. Now we'll be starting with numerical number 2 on strain energy. So let us begin with today's video lecture. A rectangular copper bar of dimensions 50 mm into 75 mm in cross section is subjected to an axial energy input of 200 Newton meter. Determine the minimum length of bar to limit the axial stress in the bar to 80 MPa. Take Young's modulus as 1.15 into 10 raised to 5 Newton per mm square. And so this is a very simple problem when compared to the previous one. So let us start with the solution. Right now here you are having a rectangular bar of cross section. So whenever he has given the cross section, I can calculate the cross sectional area AC. So that is 50 mm into 75 mm. So let me check out how much it will be. So it is 50 into 75. So it is by 3750 mm square. 3750 mm square. Right. And now we know that strain energy stored in a member subjected to axial pull is given by. So this was my first derivation while teaching you the theory part. So it is given by U is equal to 1 by 2, or you can call it as sigma square divided by 2E into volume. Right, so all of us know this expression. So therefore U is equal to sigma square divided by 2E. Volume, I'll write it as AC into length, cross sectional area into length. Right, now here in this he has given U value in the problem as 200 Newton meter. You please substitute it in mm because everything else is in mm. So it is 200 into 10 raised to 3 Newton mm. AC I have already calculated. Young's modulus is given to me in the problem. So here E is 1.15 into 10 raised to 5 Newton per mm square. Right, and sigma, so limiting stress, he has given it as 80 MPa, which is 80 Newton per mm square. So therefore, in order to calculate the value of L, only L will become unknown. Value of U is 200 into 10 raised to 3. 200 into 10 raised to 3. So that should be equal to sigma square is 80 square divided by 2 into E is, value of E is 1.15 into 10 raised to 5 into AC value is, I have calculated, that is 3750 into L. So only L will be unknown. So therefore you just simplify and check out what will be the value of L. So parallelly even I'll try here. So it is 200 into 1000 into 2 into 1.15 into 10 raised to 5 divided by 80 square into 3750. Right, so I am getting it as 1916.66 and answer will be in mm. 1916.66 answer will be in mm. So R L will be equal to 1.916 meters. 1.916 meters. Right, so that's it. That is the end of the problem. Next we'll be proceeding to the next numerical, that is numerical number 3. So this is numerical 3. A cantilever beam of uniform cross section carries a point load at the free end. Determine the strain energy at the beam and deflection at the free end. Take force applied is 200 kilonewton. Young's modulus is 2 into 10 raised to 5 Newton per mm square. Length is given as 3 meters and moment of inertia is 10 raised to minus 4 meter raised to 4. Right, so what is happening here? You are having a cantilever beam. It is subjected to a point load at the free end. Right, so the value of load is also given here. So let me start with the solution. Right, so let me draw a rough diagram of that. So let us say this is cantilever beam. It is subjected to a point load at the free end. So value of point load is 200 kilonewton. So here you are having 200 kilonewton. The total distance is 3 meters. Right, so here you are being asked to find out the deflection which is happening. That is, in this case, it is the bending force which comes into picture, or bending stress which comes into picture, because whenever this load is acting, the beam will hog, the beam will bend, or the beam will hog. Right, so let us start with the solution. So strain energy stored strain energy stored in the beam due to bending. Okay, so this is case of bending. So that is given by U is equal to integration of m square dx divided by 2ei, m square dx divided by 2ei. So that is the strain energy stored in the beam due to bending, and it is for the entire length 0 to L. Right, now I'll take this as equation number 1. So here in this case the moment is given by, so m in this case will be, this is a cantilever beam, and in a cantilever beam, how you will be moving your section, you will be moving from right to left. So this will be your direction. Right, so when this will be your direction, so moment is force into perpendicular distance. So it is 200 kilonewton into 3 meters. Right, and it will be negative. It will be negative. Why it will be negative? Reason is simple. You are moving from right hand to left hand side, and it is making a clockwise movement. Clockwise movement, when you are moving in a cantilever beam from right hand side to left hand side, it is taken as negative. This sign convention I have already told you when I was explaining shear force and bending moment diagrams. Right, so therefore m is equal to, now it is minus 600 kilonewton meter. So this is kilonewton and this is meter, but I want to express it in Newton mm. So therefore m is equal to minus 600. So kilonewton is 10 raised to 3 and meter is also 10 raised to 3 mm. So now it will be in Newton mm. Right, so therefore m is equal to, what I can say here is minus 600 into 10 raised to 6 Newton mm. Okay, so other things are known. E is known to me, I is given to me in the problem. Right, now I'll just write it here. I is equal to, I which is given to me in the problem is 10 raised to minus 4 meter raised to 4. So it is 10 raised to minus 4. 1 meter is how many mm? 10 raised to 3. 1000 mm is 1 meter. So it is raised to 4. And so therefore I is equal to, what I'll be getting, 10 raised to 12. So this is 4 into 3, that is 10 raised to 12 minus 10 raised to, sorry, into 10 raised to minus 4. So it will be 10 raised to 8. 10 raised to 8 unit will be now mm raised to 4. Right, so this is important. Everything should be expressed in mm. Now therefore equation 1 becomes, equation 1 becomes, so that will be u is equal to integration of 0 to what is L. L is in meters, so I'll put it as mm itself, 3000, right? It is in mm. Everything else is expressed in mm, so you can just check out m square. So m square is this value into 600 into 10 raised to 6. You need to square this into dx divided by 2 times value of e given to me is 2 into 10 raised to 5. 2 into 10 raised to 5. Value of I is 10 raised to 8. Right? So now you just check what all things are happening and simplify this, and then you'll be getting the value of u. So let us go ahead and simplify this. So all these constants, first let me simplify and keep them out. So it is 600 minus square will be plus itself, so I'll not consider this minus sign, into 10 raised to 6. Okay, so this value I have to square. I have got some value divided by 4 into 10 raised to 5 into 10 raised to 8. So I'm getting the value as 9000. I'm getting the value as 9000. So this entire simplification, u is equal to, I'll keep 9000 outside, integration of 0 to 3000 dx. So that is 9000 integration of 1 into dx. Right, what do you write? Integration of 1 into dx is x.